So, good morning, everyone, and welcome to today's class. Today is lecture number 27 on work, power, and energy. Actually, I think uh, we are almost done with work, power, energy, and in today's class, we would be concentrating on circular motion, circular motion, or circular dynamics is what I call it. Now, before going into this circular motion, I think I had given you a task. Good morning, Satvika. I had given you a task to solve the questions from 64 to 71, and I think I got a message from Sana, and she told me that she is having problems in I think two questions. So what I'll do is I'll just quickly go through those questions and see if I can resolve those difficulties that you have. So let me just go through those two questions. Once again, I think she was talking about question number 65. And question number 65, as you can see, this question came in one of the JEEs. A wind power generator converts wind energy into electrical energy. So this is just like a, what should I say, a windmill. It rotates and it converts wind energy into electrical energy, assuming that the generator converts a fixed fraction of the wind energy intercepted by its blade into electrical energy. For wind speed v, what is the electrical power would be proportional to? Now, basically, whenever you have this question, this is uh, somewhere a question of what I call variable mass system. We have not discussed variable mass system. Probably we'll do it after your 11th standard. Now, you might have encountered questions in fluid where you have uh, a pipe through which water is coming out, and you have to find out how much is the force with which the pipe goes back. You might have seen this question where you have a tank filled with water and there is a small hole in the bottom, and this water will come out from that hole. But when water comes out of the hole, this entire cylinder is going to go back. This was a question that came in JEE of 1997, which incidentally I gave, and I solved that question in the examination hall. So basically, this is a question of wherever you have mass, constant flow of mass hitting a body and applying force on that body, or a constant mass or mass coming out of a body at a constant rate and it is pushing the body in the opposite direction, we call it the thrust force. The thrust force applied by this mass of water or any fluid which is coming out. Now, we'll not go much into the derivation part of this, but whatever force this, for example, you might have seen all these firefighters. Some days back, I was in Indore and there was a big fire just behind my house, just adjacent to my house there. And we call this fire brigade. Now, this fire brigade people, they have this big tank, which obviously contains water, and they have this fire hose. And you might have seen two or three firemen holding that hose when water gushes out. Why this happens? Because when water is gushing out at a very large rate, the hose will be thrown backwards. Action reaction force. Water is coming out, that is action. So it will push the hose back. This is same as when you are having a gun in your hand and you shoot it, the bullet goes forward, but the gun will push you backward. Action reaction. Gun is a single body. A bullet is a single body, so that's the single mass. But when instead of a single body like a bullet, you have mass coming out at some rate, just like water, that is known as a thrust force. Thrust force. Simply force, yeah, nothing else. Now to find out this force, recoil force, yes, Yashwant, good. Recoil force is when you have this gun and you shoot it, and this gun comes back. We'll be doing a lot of question on this in the chapter of center of mass, which will be coming after this. The recoil force, or this thrust force by this water which is coming out, don't have to go much into the detail of this. This force is given by this formula. Just remember this formula: rho a v square. Rho standing for the density of the fluid which is coming out. So if it is water, density of water is 1000 kg per meter cube. So this rho stands for the density of water or whatever fluid is coming out. This A stands for the area of cross section of the pipe. This pipe, whatever area it has, A stands for that area. And this V square, where V stands for the velocity. So remember, this thrust force or recoil force by whatever liquid or fluid is coming out of this pipe is given by this formula. And if you remember this formula, rest of the question is pretty damn simple. Force is rho a v square. This is one formula that you must never forget, and that is the reason I asked you to do this question starting from 64 to 71. Sana, good job that you have tried the question. I'm not sure if everyone of us present in the class has seen this question. If you have not, well, you have missed it. Sana, this is how you do it. So force is rho a into v square. I have to find out power. Power is simply F multiplied by V. We are talking about instantaneous power here. So you multiply it by V, you will have power proportional to V cubed. And that is how this question is done. I hope it is clear. They have given the small derivation of this. You can also understand the derivation of this dm by dt. Dm by dt is the rate at which mass is coming out. If the entire mass is not coming out, it's not a single bullet, that a single bullet comes out. Mass is coming out at a rate dm by dt. So it is d by dt of m. Mass is volume multiplied by density. This density is constant, and therefore this density comes out. The only thing remains is volume. Volume is area multiplied by the length. Area is a constant. Area again comes out. It is rate of change of at what speed it is coming out. At what speed this water is coming out. dl by dt is that speed. So dl by dt becomes your velocity v, and hence you have the formula F becomes rho a v squared, and your power becomes rho a v cubed. Don't have to remember the formula for power. If you just remember the formula for force, that is good enough. That was about question number 65. I think she also has a problem with question number 71 or 72. I think question number 71 or 72, whatever she's talking about. It's a very simple question. A bus weighing 100 quintals, you have to convert quintals into kgs on a rough road. Constant speed is 72 km per hour. You have to convert it into meter per second. Friction of the road is 9% of the weight. So you first find out the weight of the bus, mass into G. Take the 9% of this. 9% of his weight is friction force, and 1% of this weight is that of air. So you have frictional force as well as air resistance. Yesterday, someone was asking me, I think it was Vahini, what is air resistance? Whenever something is moving inside a fluid, you must have read this in your chapter on fluids. Air resistance. Whenever something is moving in a fluid, that fluid will offer resistance. Water is a fluid. Air is a fluid. Anything that moves inside a fluid, that fluid, yes, Yashwant, you can also call it drag, that fluid is going to give it some resistance. Imagine you are walking inside water. Do you feel so comfortable walking inside water? No, because water is a very viscous fluid. It's a liquid, you can also call it fluid. Anything that flows is fluid. So if you are trying to walk inside water, water offers a lot of resistance, you can feel it. Similarly, when you are walking on earth, earth has an atmosphere, mixture of gases. That mixture of gases also gives you resistance. That is known as air resistance. You might have seen bullet trains in Japan and China and elsewhere. These bullet trains have a specific shape. They are shaped like this at the front. We call it streamlined. You might have seen Formula One cars. You might have seen fighter planes. You might have seen an airplane. The airplane has a nose. We call it streamlining. Why this nose is created? Because it cuts this air so that this air resistance is reduced. Air resistance. You might have heard about terminal velocity in your chapter on fluids. When you throw something from a great height, firstly its speed increases, but then when the speed increases, the resistance given by air, you might have seen Stokes law, 6 pi eta RV, resistance offered by this air is directly proportional to the velocity. As soon as velocity increases, the resistance becomes more and more. Imagine you are just walking at your normal pace, you don't feel resistance, but now you start running, you feel, oh, so much air, you are feeling resistance. Imagine now you are in a car at 50 kilometers per hour, then your car is moving at 100 kilometers per hour, then 120 kilometers per hour. Don't go so fast, you might encounter an accident. But then as your speed increases, your resistance, the resistance offered by air is a fluid, the resistance offered by air increases. Air resistance, 6 pi eta RV, Stokes law. Air is a fluid. So total frictional force, they've done total frictional force, it is frictional force plus air resistance, 9% plus 1%, 10% of the weight. You find that 10% of that weight, then you just find out you have to overcome this frictional force. So the power applied by the engine must be same as the force applied by the engine must be same as this frictional force, because you are moving at a constant speed. Just multiply force with power, multiply force with velocity, and you end up with this answer. I hope we are okay with this, Anna? And everyone else. So this is how this question was supposed to be done. Every question has something that you must understand, and that is why doing each and every question is very, very important. And that is why it is given to you. But if you don't use the opportunity that is given to you, well, you have lost it. Because now you have gone ahead. When I had given you the homework, that was the time when you had to do it. If you don't do it, you lose it, because then it becomes a backlog. And remember, you can never clear a backlog. A backlog always remains a backlog. That is the first thing that you must understand now at this stage, because you cannot keep anything pending beta. This year was a pandemic year. JEE did not happen this year. Normally JEE happens, the first attempt happens in December. So add 1 year, January of next year, and you would have given at least one attempt of JEE. Time is less. You cannot keep a backlog in your head. I hope this is good enough, and you will again go through the questions today. I wish you luck, and I can only pray that good sense prevails and you work hard. Remember, the only way you are going to clear a JEE, whether it's main or advanced, is by your hard work. Whatever I teach you or whatever anyone else teaches you is just a supplementary. We are just helping you out. I cannot make you clear JEE unless you work hard. And if you think that just attending the class, just sitting in the class, you are going to clear JEE, well, you are not going to do it. If you attend the class for 1 hour, you have to at least study after the class for 3 hours. So you're attending 3 classes. So you have to study at least for 9 hours. If you can do that, well done. The chances of you clearing a JEE is very high. If you don't do it, no one else to blame. You cannot blame anyone for your failures. Similarly, you should not give the credit for your achievements to anyone. I normally don't take it. When students get selected, I always give them the credit. When they don't, probably I take the blame. But I only take the blame when you do what I say. If you don't do what I say, and when your parents ask me, sir, what happened? I'll say, I don't know. I don't know why your son did not get selected. I have no idea about it. But if you listen to me, I will not have to say the same thing to your parents. because then you would be clearing JEE. Anyways, on that note, let us begin today's class. This was also today's class, obviously. We are discussing a question on work, power, energy. Power is the main concept here. Now, as I said, the last part that remains in this chapter concerns circular motion. And this is the part where majority of the question comes from. You will have something plays at some point, and then there will be a circular track, and you will have to find out whether it completes the circular track, this, that, lots of things. To do those questions, you must understand what is circular motion. I'm sure that you know what is circular motion because this would have been covered. I think in the other class, rotation is going on, right? Rotation is going on, rotation is finished. You started with gravitation. Anyone would tell me the update from the other sir? Rotation finished or rotation is still going on? Okay, rotation finished, gravitation started. So that means you must have an idea. If you have an idea about rotation, you must have an idea about circular motion. So the ball passes on to you. Tell me what is circular motion. Because I always tell my students that whatever is required for my class, I will teach you. If it was if it was differentiation, I taught you differentiation. If it is on integration, I taught you integration. If it was vector, vector is a topic of maths, not physics. I taught you vectors. Now, since I need circular motion, so I will have to go through circular motion again. But if you know it, that will help. Question passes on to you. What is circular motion? A body which moves in a circular path. Yes, a body which moves in a circular path. But what do you mean by a circular path? What is a circle? That is the basic question. What is a circle? A body which moves in a circular path, you can obviously call it circular motion. Circular motion is motion in a circular path. What is a circular path? Circular path is the path of a circle. Then what is a circle? That is the basic question. What is a circle? Anyone? You are maths guys. You must know what is circle. Is velocity at every point is same? Whiny? That is not correct. I'm sorry. That is not correct. You are confusing things. You confuse things. That's not good. Is velocity at any point is not same. I don't know how did you get this notion? That is wrong. Absolutely wrong. I did not talk about its velocity any ways, Vaini. I was asking what is circular motion? Moves with fixed length from a fixed point. Okay. Okay, so that seems okay. Moves with fixed length from fixed point, but what again? Still, you're not using the correct terms. You're not using correct terms. Your terms are missing. When terms are missing, that means having same radius. Having same radius. Tarun says having same radius. Okay. Still, everything is not clear in my head. See, I am imagine me as a 7-year-old kid. My son is 7 years old. Karthik is saying something. Karthik is saying what? Collection of points. It's not a collection of points from a fixed point called center. No, it's not a collection of points. You're still missing the basic essence of this. Okay. Terms are important whether you are paying for any exam and especially for your board exam. Terms are important. If you say collection of point, I will cut mark on that. It's locus, not collection. Locus. Locus is the word. I hope you know that word, locus. So a circle is nothing but it is a locus of all points. Circle is a locus of all points whose distance from a fixed point is same. Circle is not a symmetrical closed body. Hanek, you are creating definitions of your own. You cannot create a definition of something which is already defined. Moving in a curved path. No, Jagdish, that is not a circle. I'm asking what is a circle? Velocity acts tangentially. That is now how we'll define a circle, beta. I just wanted you to know the definition of circle. You are not able to tell me the definition of a circle. Maybe you don't know it. Anyways, movement of an object along the circumference. I'm asking what is circle? And you are telling me everything about a circle without telling me what is a circle. That is not good. If I ask you what is Earth and you tell me Earth rotates on its axis, Earth spins around its axis and Earth moves around the sun, I will say, "Arey, don't tell me what Earth is doing, tell me what is Earth." What is circle? Circle is a locus of all points. Locus is the word. Circle is a locus of all points whose distance from a fixed point remains constant. That fixed point is known as the center of the circle, and that fixed distance is known as the radius of the circle. This is how you define a circle. Locus of all points whose distance from a fixed point remains fixed or constant. Fixed point is known as the center, and the fixed distance is known as the center, the radius of the circle. Now, any body which is following the path of a circle, whose trajectory, physics my word is trajectory, whose trajectory is circular, is following circular motion. But again, this is not how it is defined. It is defined in the way that it is written in this book. When a particle moves in a plane such that its distance from a fixed or moving, now that point can also be moving. When you think about or when you look at the definition of circle in maths, it's always a fixed point. It is always given in terms of a fixed point, but physics is one step ahead. This point can be fixed or moving. Remains constant, then this motion is known as circular motion with respect to that fixed or the moving point. Important terms that make us understand what that motion is. That fixed point is known as the center, and the fixed distance of the particle from that point is known as the radius. Now everyone understands that the center of the circle is fixed. Everyone thinks of it that way, that if it is circular motion, the center is fixed. But remember, you have already done rotation, and you might know what is rolling, pure rolling. Now imagine the motion of a wheel which is moving on ground, which is in pure rolling. Now imagine a point. Imagine this is a wheel which is rolling. So it is moving with a velocity v and it is rotating with an angular velocity omega. This is the center C. Now if you look at the motion of this wheel and you imagine a point on the circumference of the wheel or the tire, point A. Now if you imagine the motion of this point and if you look at the motion of this point from standing on ground, the motion is very complicated. The motion, how does the motion look like? How does the motion look like? If you're standing on ground and looking at point A, how does the motion of the point A look like? Will it look circular? That is the question. Does it look circular? There is a wheel rolling on ground, wheel of a car, wheel of a cycle, truck, train, whatever. And you're imagining a point on the top of that wheel or wherever. And you're looking at its motion, standing on ground. How does the motion look like? Anyone? Simple question. How does the motion look like? You have already done rolling, right? How does the motion look like? No answers? Okay, I'll make the question simpler. Does the motion look like circular motion? Is it a circular motion? Is the trajectory of this particle, point A, circular? Teja says yes, the motion is circular. Anyone else would like to say anything about the motion of this point A on the wheel, on the rim of the wheel? How does the motion look like? point A is going to move. How does the motion look like? I am standing on ground. No one has any idea. Time to wake everyone up. I think everyone is still sleeping. Parallel to V, circular and translation. Circular and translation. Looks confusing to me. Maybe correct, but still looks confusing to me. It is definitely not circular. It is definitely not circular. In fact, the trajectory of this particle is known as cycloidal or cycloidal path. The motion is known as cycloidal. This word comes from cycle, cycle ka wheel. The motion is cycloidal. It is a very complicated motion. We'll study this motion in different ways, but this is not the time to do it. So I leave it at this point in time. As I tell you, I always tell you things on a need to know basis. You don't need to know it right now. Whenever you need to know it, I will tell you about this. This motion is definitely not circular when I'm looking it from ground. But now I change my reference frame. Now I change my reference frame and now I sit. Now I sit the red one, the red Hulk. This red Hulk now sits at the center of the circle and he moves with the center of the circle. The blue Hulk was on ground. He was watching everything from ground. And it's a complicated motion. It's a cycloidal motion. To get the equation of this motion is tough. I'll tell you an easier way to do it. But it's tough. But now this red Hulk, the twin brother of this blue Hulk, sits. My son says that Hulk are of different colors. I only know one color. Hulk is always green. And he's seen blue Hulk, red Hulk. I don't know where. Okay, this red Hulk now is at the center of the wheel. Now I ask the same question. He's moving with the wheel. He's moving with the center of the wheel. Wherever the center of the wheel goes, he also goes. Red Hulk. Now you become the red Hulk. Now how does the motion look like? Of this point A, how does red Hulk see now? What does red Hulk see? How does the motion look like? How does the motion look like? Anyone? Yes, Santosh. Now it looks circular. It is not looking circular. It is definitely circular. To the red Hulk, the motion is definitely circular. Yes. So it is easier to understand this motion, not from ground, but from sitting on the top of, but by sitting at the center of the wheel. The motion is circular. And that is how you understand this moving point phenomena. So if I become the moving point center, here the center of the circle, which that body is following. Now this circular motion is with respect to the center of the circle. Remember, this is not circular motion with respect to the ground. I hope that point is clear to everyone. This point A is following circular motion, but not with respect to ground. It is with respect to the center of the circle. Can I have some raise hand that we understand this? Just to make you understand this moving point and fixed point, I had to tell you all this Ramayana starting from rotation till all this. And that is how you understand the definition of something and it becomes embedded in your head. Only 14 people have said yes, which is less than 50%. Not good, not a good sign. It's going up, but still less. What about the others? Let me wake everyone up. It's time to wake up. If you don't wake up now, it would be too late to wake up. Then you probably keep sleeping. Yashwant, Harshita, Satya, Satvika, Sai, Reddy, Yashwant, Padmakan, Sachank, Kevin, Josna, where are you guys? Still there? Same universe? Are we in the same universe? Yes, this is a good universe to live in, where physics is simple. V is equal to u plus at for constant acceleration. This is a good universe. Let us not get into a multiverse. Meta. Facebook has become meta. Let us not get into metas. Let us remain in this universe. This is a good universe to live in. So, this is how you define circular motion. Circular motion, if a particle is following a path in such a way that is distance from a fixed or a moving point in some cases. Now, whatever questions we are going to do, the point will not be moving because the moving point comes in rotation. So I don't have to worry about the moving point, but you have to understand that a point can be moving. That is why I told you all this. So is distance from a fixed point or a moving point is remain fixed, then that motion becomes circular motion with respect to that given point. This given point can be fixed, this given point can be moving, this given point can be accelerating, doesn't matter. This motion is known as circular motion. The fixed point or the moving point or the accelerating point is known as the center of the circle, and the distance of the particle from that fixed point, moving point or accelerating point is known as the radius of the circle. I'll give you a minute to note this down. If you have any problems, anything that is troubling you, please ask. 1 minute to note it down. I hope you have noted down. Oops. I hope you have noted down the definition of circular motion, and you should not forget it now, because after this we will not be revising it anymore. That was circular motion. Now, if you talk about circular motion, or if you talk about rotational motion, pure rotation, if you remember the definition, pure rotation can be thought of a circular motion of all these different points. They can have different radiuses, but their center lie on the same line, and that is pure rotation. Now, whatever terms we have studied in what I call translation motion, I hope you have gone through this. Motion can be, number one, let me write it. Motion can be, number one, pure translation. It can be pure rotational, or it can be mixed or combined or plane motion, which is a combination of translation and rotation. Now, we are not talking about rotation, we are basically talking about circular motion. Now, translation motion means motion in a curved path is also translation. Translation and rotation are quite different. Now, basically what I mean to say is, whatever terms we have seen in the normal motion that we have studied, it was translation. Circular motion is still translation. Rotational motion is rotational. Circular motion is still translational. But we'll have similar terms that came in your translation motion. We'll have similar terms for rotational motion or circular motion. Circular motion is still translational. Remember that. Don't get confused. Now, in normal motion that we were talking about, we had position vector. We had two axes, x-axis, y-axis. We had three axes, in fact, but we did not go into three-dimensional motion. We had x-axis, we had y-axis, and then we had a point, and we found out the position of this point by drawing a vector from the origin to the point, and that vector was known as position vector. It was a vector, therefore position vector. I hope everyone remembers that. Now, when somebody is following circular path, remember circular motion is also translational. When somebody is following circular path, we can also always study its motion from that aspect, that I draw two axes, then I draw an origin, and then I draw a vector from origin to point P. If I do that, let us do it here. This is a body which is following circular motion. It is moving in a circular path. Who is disturbing me? I hope none. Okay, done. So this particle is following a circular path. To understand its motion, I need two axes, x-axis, y-axis, already there. I need an origin, already there. Now I can always draw a vector from origin to point P. That becomes my OP vector. That will give me the position of this particle P with respect to O. If it changes its position, I can draw a second vector from O to P dash, its new position, and that will give me the new position vector of this particle. If it goes somewhere else, if it goes here, let us say P double dash, I can again draw a vector from O to P double dash, and I can repeat the same process for all these points, on the circle. But again, you can understand that it becomes very difficult, and it's complicated. It's difficult to understand the motion of this point P in terms of position vector, because we are just complicating a very simple thing. Now, instead of giving you the position of this particle P in terms of position vector, it would be rather more simpler, and I will just erase everything off. It will be rather more simpler, and everything has been erased. It will be rather more simpler to just tell you, obviously there would be two axes, x and y. There would be a center of the circle. Now what I take is the center of the circle as the center of this, as the origin of this axis system. I just tell you two things. I just tell you where is the center, which is already known, and I just tell you the radius of this center, the radius of this circular path, center and radius. Now to find the position of this particle P, I only need to tell you one thing. If you know the radius, if you know the center, to know the position of this particle, I only need to tell you one thing, and that is this small angle theta, small or big, whatever. I just need to tell you this angle theta. Telling you this angle theta together with the radius, and if you know the center, you can very easily find out where the particle is. I don't have to tell you the position vector, I vector, j vector, falana, demma ka je wo. Does it make sense? We are trying to simplify life. We are not trying to complicate it. We are not studying quantum physics. Quantum physics is complicated. We're not studying that. We're studying simple mechanics. Mechanics is also complicated, but we are studying a very simple portion of that mechanics. I don't want to make your life complicated. It has to be simple. If you know the radius, you know the center, I just tell you this angle theta. This angle theta now will tell us the position of any particle wherever it is following a circular path. If this angle is 30 degrees, you just mark 30 degrees, the point is here. If this angle is 60 degrees, mark 60 degrees, the point is there. 90 degrees, it will come here. 180 degrees, it will come here. 270 degrees, it will come here. On 360 degrees, it will again come back. Now, we'll not say this angle in terms of degrees, because degree is not the SI unit. We'll always give you this angle in terms of radians. Am I clear with this? I always give you this theta in terms of radians, and this theta is telling us the position of this particle if I know the center and the radius of the circle, and therefore this theta is known as, it gives us the position, so it is position, but it is in terms of an angle, and therefore it is known as angular position. This is the first thing that you must remember about a circular path. To know the position of any particle which is following a circular path, we need the center, number one, we need the radius, number two, then we only need the angular position, which is the position of that particle given in terms of an angle. This angle has to be in radians. Do we understand this? Can I have some raised hand that we understand this? Angular position. I'm only having 15 raised hands. Must be more students in the class. Angular position. Now this angular position is doing the same thing in circular motion. Mark my words. This angular position is doing the same thing in this circular motion which position vector was doing in that previous thing. So this angular position is same as position vector. Position vector, angular position. Angular position, position vector. But the subtle difference is this was a vector. This is just an angle. So it is scalar. This is a scalar quantity, just an angle. This was a vector. Position vector, angular position. position vector, angular position, same thing. They are telling us the position of this particle, and in circular motion it is always easier to give it in terms of this angle. Now the second term is, let us first write this. So I'll give you a minute to draw this diagram. You write this angle theta. This angle theta is angular position. This angle theta is angular position, and the definition of angular position goes like this. I'll read out the definition for you. I hope you have drawn this diagram. It was very simple. And the definition simply goes like this. To decide the angular position of a point in space, we need to specify origin and reference line. The angle made by the position vector, again the position vector comes. The angle made by the position vector with respect to origin with the reference line is known as the angular position. You have to just write the underlined part. Then it's a description. Circular motion is a two-dimensional motion or motion in a plane. Suppose a particle P is moving in a circular radius of center O. The angular position of the particle P is at a given instant may be described by an angle between OP and OX. This angle is known as the angular position of the particle. Done and dusted. Everything that we have discussed. I'll give you a minute to note things down. Remember, it is a scalar quantity. Remember, it is a scalar quantity and the SI unit is radians. SI unit is radians. It does not have any dimension, but it has a unit. Remember, angle is one thing that has a unit but no dimension. I hope everyone has noted this down. Okay, angular position, same as position vector. Now see, this particle is moving in a circular path, its position is going to change. At one point, the position was P. At some other point, the position would be P dash. The position has changed. Particle has moved. Particle has been displaced. Displacement vector, change in position vector. Position vector has changed. The particle has displaced. That was displacement vector. Here, the position has also changed. I cannot call it displacement vector. It has changed. Change is always given by delta. Delta theta. Delta means change. Theta means angle. Delta theta means change in angle, change in angular position. And that change in angular position is known as angular displacement. So angular displacement is the next term, which is change in angle or change in angular position, which is final angular position minus initial angular position. Theta 2 is the final angular position, which is the angular position of point P dash. Theta 1 is the angular position of point P. Theta 2 minus theta 1 becomes your change in angular position, which is known as angular displacement. Is it clear to everyone? Can I have some raised hands? So in one diagram, you have got two definitions. One is the definition of angular position. The other one is the definition of angular displacement. Angular displacement is nothing but change in angular position, delta for change, theta for angular position, theta 2 minus theta 1. I'll give you time to write this down. Only 8 people have raised hand. What about the others? I hope everyone is writing. And just wake everyone up. Yashwant, Veronica, Venkatesh, Harshita, Siddharth, Satya, Sana, Satvika, Sai, both sides, Padmakant, okay, Shashank, Karthik, Kevin, Jyotsna, Santosh, Deepak, Ajay, Aishwarya, everyone is there in the class. Okay, I'll give you time to write it. Same thing, one is angular position, one is angular displacement. First write angular position, I'll give you a minute. I hope you have written the definition of angular position. We will move on to angular displacement. What is angular displacement? I'll give you time to write this. Angle through which the position vector of the moving particle rotates in a given time interval is known as angular displacement. This much is enough. Denoted by letter delta theta. Delta standing for change, theta standing for angular position. Theta 2 is the final position, theta 1 is the initial position, theta 2 minus theta 1. Again, the SI unit is radians. It does not have any dimension because angles are dimensionless. I hope you have noted this down. Now, the important points about angular displacement that you must remember. The first point is angular displacement is a dimensionless quantity. SI unit is radian. Some other units are degrees and revolution. 2 pi radians is 360 degrees. That is equal to 1 revolution. Everyone knows this. It is not difficult to understand. Point number 2, what type of quantity is angular displacement? Well, angular position, as I said, is a scalar quantity. What about angular displacement? Now, it is a scalar as well as a vector. Infinitesimally small angular displacement is a vector. So if I write it as d theta, which is very, very small change in angle, this d theta is a vector. Very small change in angular position or very small angular displacement is a vector, but a large change, which is delta theta, delta means large change, delta theta is a scalar quantity. And why it is that so? It is a scalar as well as a vector. Because if it is a vector, it must obey addition law. It does not obey addition law. D theta 2 plus d theta 1 is not equal to d theta 2 plus d theta 1 plus d theta 2 is equal to d theta 2 plus d theta 1 plus 3, but theta 1 plus theta 2 is not equal to theta 2 plus theta 1. That means if the change in angle is more, it is a scalar quantity because it does not obey commutative law, does not obey commutative law. For large change in angular position does not obey commutative law. Small change in angular position obeys commutative law. How would you understand this? My phone is being taken away. Bottle. Now remember, it is a vector, and which type of vector it is? It is known as an axial vector. Whenever we talk about angular things, whether it is angular velocity, whether it is angular position, angular displacement, small angular displacement, angular acceleration, torque, angular momentum, all these are axial vectors. Their direction is given in terms of axis. How it is in terms of axis? This is positive direction of x-axis. This is positive x-axis. Positive x. If something is rotating on positive x, how do I find its rotation? It is decided by the right hand thumb rule. What is the right hand thumb rule? This is positive x-axis. I hold my right hand, my thumb points in the direction of positive x, and see how my fingers are rotating. So if something is rotating like this, it is rotating on positive x-axis. How does something rotate on negative x? How does something rotate on negative x? I hold negative x in my right hand. If something rotates like this, it is rotating on negative x. How does something rotate on positive y? I hold positive y in my hand. If something rotates like this, it is rotating on positive y. How does something rotate on negative y? This is right hand thumb rule. Now, why this is not commutative? Why this is not commutative? I will try to explain it by rotation, and let us see if you can understand this by rotation, and you can do it at your home. That will be the last activity for today's class. This bottle, I am going to rotate it on two axes. I am going to rotate it on, say, x and z. I will rotate it on this axis, and I will rotate it on this axis, this axis and this axis, this axis and this axis. First of all, let us rotate on this axis. How does it rotate? It rotates like this, tongue, 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 tongue. So I rotate it on this axis. Oops, water is coming out. I must. Okay, it was like this. I rotate it on this axis. How does it rotate? Tongue. Okay, I rotated on wrong tongue. It will rotate like this. So 90 degrees I have turned it. It now becomes like this. Again, water is coming out. I'll have to use something else, which okay, this one. There is no water here. Okay. So I rotate it on positive. I rotate it on this axis. It goes like this. Now I rotate it, let us say, on the y-axis, like this. Okay. First I rotate it on this axis. If I rotate on this axis, it becomes like this. Now I rotate it on positive y-axis. So it rotates like this, 90 degrees. So now it becomes this. It was like this. First I rotate it like this. Then I rotate it on the y-axis. It is like this. You see this? You understand this? It has now become like this. Now I'll do the ulta thing. First, I will rotate it on y-axis by 90 degrees. So it goes like this. Then I rotate it on this axis by 90 degrees. Now it is like this. See? It is not commutative. Once I rotate it like this and this and this, it was like this. If I did the ulta, first I rotate it like this, then I rotate this, it is like this. In first case, it was like this. In second case, it was like this. Do we understand this? Why it is not commutative? Can I have some raised hand that you understand this? You can do this at home. Take anything and rotate it on two axes and see, is the orientation same in both the cases? It will never come same in the both the cases. But if you do it for very small angles, it will come same, almost same. But for large angles, it will never come same. And that is why delta theta is a scalar quantity and d theta is a vector quantity. The direction is given by right hand thumb rule for all these vectors, which are axial vectors: angular displacement, angular velocity, angular acceleration, torque, angular momentum. All these are axial vectors. I'll end this today's class here. I hope you enjoyed it. We'll meet in the next one. I hope, Tarun, the point is clear to you. Why it is not a vector, it's a scalar, does not obey commutative law. We'll meet in the next class. I hope you enjoyed it. See you. For the next one, if there's any doubt, please come up to me. The class from my end is dismissed. Over. Take care. Have a nice day. Stay home. Stay safe. Get vaccinated. If you are eligible, get vaccinated. That is the only protection that you have against this virus. Trust me. I have taken my 3 doses. You should also take it. Take care. Bye bye.